Hi friends, in this class we will solve some problems using KCL and KVL and also other other laws, Ohm's law, then current division, voltage division, all these rules also we will apply and solve the problem. So let us take up this example. Example 1, this find out all the branch currents of the given circuit. This is a circuit. This is the given circuit. Now I'm going to draw the given circuit here. Given circuit as this is 16 ohm, then here it is 5 ohm, 20 ohm, this is again a 20 ohm resistor. Here we have a 10 ohm resistor, then plus minus 100 volt. 100 volt is equal to so the circuit given is looks like this. Now the examiner want to find out all the branch currents of the given circuit. Means current is across 10 ohm resistor, then 20 ohm resistor, then 5 ohm, 20 ohm, then 16 ohm. All these resistors. Now let us find out the number of nodes. What are the nodes? Here we have a node, a symbol node N1, symbol node N1. Here we have a principal node N2, and here we have a symbol node N3, and this node is same as this and this, so together we have N4 node. Now while analyzing a circuit by nodal analysis, what we have said that we ignore all the symbol nodes. Here the symbol nodes are N1 and N3, and we have two other than the symbol nodes, we have two nodes known as principal nodes, N2 and N4. So I'm going to ignore this N1, N3 and N4. And I'm considering only the principal nodes N1 and N2. And From these principal nodes N1 and N2, I am taking one of the nodes as reference node N2. This is my reference node N2, and this reference node N2 is connected to the ground. We are assuming that this reference node, which is also a principal node, is connected to the ground, so it will be having a zero potential or 0 volt. And let us assume that the node N1 is having a voltage V1. Okay. Now I'm considering, or I'm assuming, currents in this direction. Here I have some I3 I have, I2 I have like this in this direction, and this direction, and I have I1 in this direction. I am assuming the current direction as shown in the figure. Now I am applying KCL, Kirchhoff's current law, KCL at node N1. So what happens is, the algebraic sum of current entering or leaving the node is equal to 0. So here all the currents, I am assuming that all the currents I1, I2 and I3 are leaving the node. No current is entering into the node. So when we apply KCL, I will get I1 plus I2 plus I3, which are the currents leaving, that should be equal to entering current. Here no current is entering, so it is equal to 0. This is my KCL. Now I am applying Ohm's law. Okay, Ohm's law for all these branches associated with the node N1. Now I have the current I1 to the resistor 10 ohm is actually, by Ohm's law, it is voltage across it divided by the resistance 10 ohm. The voltage across this 10 ohm will be the voltage at this node V1. Okay, it will be potential difference between the points, this N1 and this point. Let us say this is P point. So the potential difference will be like this, N1 minus NP. That is V1 minus Vp. Okay, that will be the potential voltage drop across the 10 ohm resistance. So in this point P of the circuit, we have 100 volt here plus 100 volt here. So we have a battery connected to this point. So this plus minus in this polarity. So this battery voltage plus 100 plus 100 will be 100 volt will be appearing at this point. So, and we have V1 here, V1 voltage here. So for the assumed direction in this direction, the current always flows from higher potential to lower potential, always. So the voltage drop will be like this, plus minus, like this, higher potential to lower potential. So I'm assuming I have, so by that assumption, I have V1 voltage is greater than 100 volt. So my I1 will be I1 will be equal to V1 V1 minus 100 divided by 10. So this will be my I1. Okay, I'm calling it as 1, and this equation I have A. Okay, similarly I have I2 leaving the node. So then the potential by Ohm's law, it will be the potential difference across 20 ohm divided by 20 will be the I2. So I2 current will be I2 equal to V1 minus 0, okay, divided by 20. That's equal to V1 by 20. That's my equation number 2. Now I3 will be equal to yes, I3 is the current flowing through this effect through this effective parallel combination of 5 ohm and 20 ohm as well as 60 ohm. So parallel combination of, first of all, you have to reduce this 5 ohm and 20 ohm parallel combination into a single resistance. That will be equal to, by applying that R1 R2 divided by R1 plus R2 formula, then I get 5 into 20 divided by 25, 5, 5, 5, 4. Yes. So 4 ohm will be the effective resistance. So here we get 4 ohm and 4 ohm plus 16 ohm. So 20 ohm will be the effective 20 ohm. Now I will make this circuit as like this. Yes, this is my N2 node, which is at 0 volt potential, and this is my N1 node, which is at V1 potential. So this is 20 ohm and this is I3. So I3 will be equal to V1 minus 0 divided by 20. That will be equal to that will be equal to V1 by 20 ampere again. This is my third formula. Now I'm substituting. Okay, substituting 1, 2 and 3, okay, in A. So I1 plus I2 plus I3 equal to 0. That means I get V1, okay, V1 minus 100 divided by 10 plus V1 by 20 plus V1 by 20 equal to 0. So now I will get, on solving this, I will get 2 V1 okay, I'm writing here. So I will get V1 by 10 plus 2 V1 by 20, okay, minus 100 by 10. So what you get, minus 10 equal to 0. So 2 10. So 2V1 by 10 equal to 10. That means V1 equals to 100 by 2. That's equal to 50. This is my answer for the, so I find out the I have this node voltage V1 as by applying KCL I have find out it as 50 volt. So this 50 volt, then I will be substituting this 50 volt to in this equation 1 equation 2 and equation 3, so that you will get I1, I2 and I3 currents respectively. Okay, now I1, so I1 equal to V1 minus 100. V1 means 50, 50 minus 100 divided by 10. That means equal to minus 50 by 10, that's equal to minus 5 ampere. So what do you mean by this minus negative sign? The negative sign indicates that the assumed direction is wrong and you have to negotiate the assumed direction. That means you have to take negative of that assumed direction. So the negative of the assumed direction will be the negative of this is positive direction of I1. So the negative direction of I1 will be just opposite like this. Yes. Okay. Now so this is minus 5 ampere. This is the answer. Now I have this. I have this I2 equation. I2 equal to V1 by 20. V1 by 20. I2 equal to V1 by 20. V1 I have found out that 50 by 20, that's equal to 5 by 2, that's equal to 2.5 ampere. I2 is positive. I2 is plus 2.5 ampere. So that means that this I2 direction of I2 is positive direction. That means in your assumed direction, and its magnitude will be equal to 2.5 ampere. Now I3, okay, I3 to get I3, I'm substituting for V1 in 3. So 50 by 20, you will get the same magnitude and same direction of the I3 current, that is 2.5 ampere. 2.5 ampere. Okay, this is my what do you call nodal analysis. KCL, applying KCL. Now yes, 2.5 ampere is the I3 current. Then what my next problem is, suppose examiner asked that you have to find out the current passing through the 5 ohm resistor in this given circuit. Then what you have to do is, you got this 2.5 ampere. 2.5 ampere, that is the total current. This is the 2.5 ampere current. So this 2.5 ampere, what happens is 2.5 ampere will divide and goes to this 5 ohm and 20 ohm resistances, and then again joins together, and 2.5 ampere will go into this 16 ohm resistance. So this is the method. This is the a concept of this 2.5 ampere. So the 2.5 ampere is the total current, and this 5 ohm I have to find the current through the 5 ohm resistor. So the examiner asks like that. Then what happens is yes, this. So my problem will be like this: 5 ohm. Okay, 5 ohm will be 5 ohm, and this will be 20 ohm, and the current is 2.5 ampere. 2.5 ampere. Now I am applying the yes, current through the 5 ohm, that is I5 ohm. Okay, that should be equal to, I am applying the current division rule. That means the total current into 2.5 into the other resistance, that is 20 divided by total resistance, 20 plus 5, that's equal to 2.5 into 20 divided by 25, which means yes, this is 10 inverse, that is equal to 2 ampere. So 5 ohm resistor will be 2 ampere, and to 20 ohm it will be 0.5 ampere. So this is the problem. Yes, this is the problem. Okay. Now, so the entire problem is solved. Now, uh, now I'm just going to verify the KVL here. Just verify. I'm going to verify the KVL. So only the verification. Okay, verification. So okay, this is my this is my this is my problem. Is plus minus 100 volt E. Okay. Mm. This is my 16 ohm. This 5 ohm, 20 ohm, 5 ohm, this 20 ohm, 20 ohm, 10 ohm, and I have this current flowing through 10 ohm uh, as as I1 5 ampere. Yes, this is 5 ampere, 5 ampere current, and through this 20 ohm I have 2.5 ampere, and here this I have 2.5 ampere again. Now I'm going to uh, just verify the KVL, Kirchhoff's voltage law. So in order to apply the Kirchhoff's voltage laws, I have to find out the loops. Here there are another first loop like this and another loop like this. Okay, this is L1, this is L2, and this is L3. L3, and this is the outer loop, the bigger loop. Yes, this is another loop. And remember that is L4. L4. Okay, now I'm applying KVL for the loop 1. That means the law of conservation of energy. That is the algebraic sum of the voltage drop across a loop. Or around a loop is 0. That means 100. Let me check whether I will get 0 or not. If you are not getting 0, then your whole analysis is wrong. So 100 I get, plus minus plus is clockwise I'm taking, so plus 100 volt. Then here the voltage drop plus minus, because current direction is in this direction from left to right. So current will always flow from higher potential to lower potential, so it will be plus and this will be negative. So from I'm going in clockwise direction, so plus to minus, it is a falling potential, so it is negative. So minus, yes, minus the voltage drop across 10 ohm, the voltage drop across 10 ohm, let it be V1. So 100 minus V1, okay, 100 minus V1, and then again I'm going in clockwise direction. I will meet this 20 ohm resistance, and the 20 ohm resistance, through this 20 ohm resistance I have 2.5 ampere current from up to down. So from higher potential to lower potential. So the sign will be like plus minus in this manner, and yes, so it is again a falling potential, so it is again, so, and I am assuming that the voltage drop across 20 ohm is V2. So V1, so 100 minus V1 minus V2. Okay, this is my KVL equation. So it must be equal to 0. So I'm checking this whether I really get this is equal to 0. So V1 we have applying Ohm's law. We have current through the 10 ohm resistance 5 ampere and resistance 10. So by Ohm's law V is equal to IR. So 5 into 10, so 50 volt. So I got V1 50 volt. So I will write it as 100. Okay, 100 minus 50, then minus V2. V2 is again yes 2.5 into 20. That means yes 5 by 2 into 20, 2 yes 5, that means 5 by yes 5 by 2 into 20, that means 10 into 5 again 50. Yes, so 100 minus 100, that's equal to 0. So yes, so the KVL is satisfied here. So that's the problem. Then in the same manner we can yes verify the KVL in all these loops named as L2, L3, L4. So you do that. Moving on to the next problem, where you have to apply both KCL and KVL in order to find the current through an element, that is resistance in this example. So I'm considering this again a circuit like this. Yes, I have a resistance 30 ohm resistance connected to a battery, 90 volt battery plus minus polarity, and I have another 30 ohm resistance connected like this. Then I have a 10 ohm resistance and 30 ohm is again a 30 ohm and again a 30 ohm. Okay, and my current, the current through 10 ohm resistance, which is marked in the given direction, is denoted as I. Okay, and you have to find out I equal to dash ampere. Okay, I is how much ampere? That's the question. So we will do this by two methods. First method is nodal analysis. Okay, nodal analysis. Actually, nodal analysis we have already done. So we will do in the second as second method. First, we will do mesh analysis. Analysis in where KVL is applied. Okay, because voltage law. Okay, in mesh analysis, or in order to apply KVL, first you have to identify the loops. This is loop 1, again another loop, again another loop, and also an outer loop is also there. Okay, an outer loop is also present, but the thing is outer loop like this is also present, but the thing is when you are carrying out the mesh analysis, only meshes are considered. Meshes means, recall that definition of mesh. Mesh means loops only, but which is not having closed path within the loop. So in this loop, which is marked in yellow color, it is a loop. it is a loop, but it is not a mesh because inside this loop we have so many closed paths. So it cannot be considered as a loop, as a mesh. Sorry, as a mesh. So we have three meshes. Okay, three meshes, M1, M2, and M3. You can call it, and the and let the current flowing through the mesh, first mesh is I1, and the second mesh is I2, and the third mesh is I3. So these are the mesh currents or loop currents flowing through the respective meshes or loops. Now I'm going for the mesh analysis, that is in which KVL, Kirchhoff's voltage law, is applied. Yes, KVL, applying KVL for the first mesh or first loop, mesh 1 M1, let us say, applying KVL for M1 means I have the current through the 30 ohm resistance. Current, you have to closely observe what is the current through the 30 ohm resistance. 30 ohm resistance is carrying a current I1. Okay, when I am considering mesh 1 in which I1 current is flowing, so I'm always saying with respect to I1. So the I1 is like this 30 ohm resistance. So the I1 is flowing downwards. I1 is flowing downwards, whereas I2 is flowing upwards. So with respect to I1, I'm saying, so I'm considering it as I1 minus I2 current, because I1 and I2 are in opposite direction. So when you algebraically sum these two currents, then I will get I1 minus I2 flowing through the resistance 30 ohm. So yes, now I'm going to apply the KVL. When you are applying KVL considering a mesh, then what Kirchhoff said in his voltage law is that the algebraic sum of voltage drops around a closed path is 0. That means plus 90. Okay, I'm taking the old convention, okay, that you know. Then plus 90. Then here I1 is in clockwise direction. We are also moving in clockwise direction. So the voltage polarity will be plus minus, that is falling potential. So minus, okay, minus I1 into 30. Okay, that is the voltage drop across 30 ohm. Then this I1 minus I2 current is flowing in downward direction, right? Because with respect to I1 I am taking, so I1 is going downward, I2 is going upward. So if you sum it, algebraic sum is I1 minus I2, and it will be in the direction downward. So we will get, so downward means again the polarity of voltage drop will be falling potential. Okay, that is plus here and minus here, because from higher potential to lower potential the current will flow. So then I will get the minus. Falling potential means minus. Then the current is I1. Okay, I1 minus I2. I1 minus I2 into 30. Okay, equals to 0. This is my KVL. Now I am rearranging this equation so that I will get only I1 and I2. Okay, then I will get like this: 90 minus 30 I1, okay, minus 30 I1, okay, plus 30 I2 equal to 0. That means minus 30 I1 minus 30 I1 minus 60 I1. So 90 minus 60 I1 minus 60 I1, okay, plus 30 I2 equal to 0. That means my first equation is like this. I'm taking this I'm keeping this 19 on LHS and taking this I1 I2 terms into RHS. Then I will get 60 I1, okay, minus 30 I2 equal to 90. This is my equation 1. Okay, now yes, this is my equation number 1. Similarly, I'm going to apply KVL for the next mesh or next loop. Okay, and this, my convention is always in clockwise direction. The mesh currents or loop currents are flowing in clockwise direction only. So the same logic that of loop 1 or mesh 1 is also applied here, is applicable here. So what you will get is this. Yes, first of all, I'm going to mark this voltage drop across 10 ohm like this, plus minus. Yes, then voltage drop across 30 ohm will be like this, plus minus, because I2 is the reference and I2 is going downwards and I2 is going in this downward direction, I3 is going upward direction. So I2 minus I3 will be the current flowing through this 30 ohm resistance, and that too in I2's direction, that is in downward direction. So, and downward direction means it is a falling potential, that is plus. The polarity must be like this, plus here and minus here. Okay, and then again coming back to this 30 ohm, our uh, our mesh is this I2 mesh. So with respect to I2, I will be writing this mesh KVL equation, so that the I2 minus I1, I2 is going upward, I1 is going downward. So I2 minus I1 will be the current flowing through this 30 ohm resistance in the I2's direction, that is the upward direction. That means in upward direction means the voltage drop will be, the polarity will be having like in this plus here and minus here. Okay, now I'm going to write the equations. First of all, I2 into 10, that will be minus 10 I2 minus sorry, minus 10 I2 minus 10 I2, then plus minus and also it will be I2 minus I3 into 30, minus I2 minus I3 into 30 into 30, and then I have this voltage drop plus minus here, so it will be minus again minus I2 minus I1, right, I1 into 30 equals 0. 30, okay, I2 minus I1 into 30, yes, 30 equals 0. This is my equation. So again I have minus 10 I2 minus 30 I2 plus 30 I3 minus 30 I2 plus 30 I1 equal to 0. That means minus 10 minus 30, yes, minus 30, minus 60 minus 70, you will get minus 70, right, minus 40 and yes, minus 70, minus 70 I2 I get 70 I2 cut, then plus 30 I got, plus 30 I1 also I have 30 I1 minus 70 I2 plus 30 I3 equal to 0. This is my second equation. Now moving on to the next loop or next mesh of I3. Next mesh of I3. Now again I have to first of all find out the voltage drop plus minus here plus minus here. Then again with respect to I3 I am saying so I3 will be upwards and I2 is downwards, so I3 minus I2 is flowing in the I3's direction, that is in the upward direction, so the voltage polarity will be plus here and minus here. And then again I am applying the KVL, then I will get as minus 30 I3 minus 30 I3 okay minus minus 30 I3 minus 30 I3 again 30 I3 is 30 I3 then again minus I3 minus I2 minus I3 minus I2 into 30 and that loop that mesh is completed, so equal to 0. That means minus you will get minus 90 I3 okay, then plus 30 I2 equal to 0. This is equation number 3. Now you solve equation 1, that is equation 1, this equation, and then you solve you consider this equation and this equation. So solving 1, 2 and 3 equations, you can do it by using your calculator and also by substituting for this I1 here, okay, from previous, then you will get the answers for I1, I2 and I3 equals to some. Yes, let me use my calculator first of all. Okay, so I got I got I1, I2, I3 as 2 ampere, 1 ampere and 1 by 3 ampere, that is 0.333 ampere. So this is my answer, and if you have any doubt you can contact me. Okay, yes, answer. Okay, that means I1 2 ampere, 1 ampere, 1 by 3. Okay, means this is 2 ampere, and this is 1 ampere, and this is 1 by 3 ampere. I1, I2, I3, 2, 1. Okay, now so this is my mesh analysis. I got the loop currents I1, I2 and I3. Now I'm going to find out the current through this 30 ohm resistance. We will take first of all 30 ohm resistance, it will be I1 current, so it will be 2 ampere. Then what about the current flowing through this 30 ohm resistance? It will be this I1 minus I2 in the downward direction, that means 2 minus 1, that is 1 ampere in the downward direction. 1 ampere in the downward direction. Okay, that will be the will be the yes answer. Now I have to find out, the examiner told you to find current I is dash. This is our actual problem. So this I, by mesh analysis, this I is same as your I2. So that is what nothing but 1 ampere. 1 ampere is my answer. Okay. So, in that way you can find out the current through different elements. Okay. Yes. That is our problem using mesh analysis. Now using nodal analysis, the same problem you can solve it. So I'm leaving that analysis for you, that is nodal analysis, okay, for the time being.